Today, I want to talk about the modeling with respect to how our brains store information, process information, and how we can model based on the brain, how the brain stores information. So I'm going to spend a minute just talking about myself. I've been an architect, developer, programmer, designer all my life, 20 years, and then afterwards, I said, I'm repeating myself whenever I'm going to the clients. So I wanted a mechanism where instead of building a specific system, I wanted to create a general purpose system that can configure itself, morph into whatever problem domain that you are trying to solve. So my inspiration came from the brain, how we human beings capture information, process, store. So I'm going to talk a little bit about the brain and how we store information. So the human brain has 100 billion neurons. So think of this as these are all neurons in your brain. And each neuron represents a certain type of information. So, it could be, if you are listening to this talk, okay, Sudhakar Moparthy, so there is a neuron, there is a connection that is happening in your brain that you remember Sudhakar, and this is a lightning talk, and then there is a connection that is happening right now. And then it is happening at 3:30. So there is a 3:30 neuron or object. So that's connected. So because of this information in your mind, in your brain, these three neurons, somehow they are getting connected. Each neuron in our brain has 10,000 synapses. So each synapsis is nothing but a certain piece of information that is you're storing. So imagine these 100 billion neurons connected to one another. So there are trillions of connections. Ever since we are born, we have been learning, and then all that knowledge is stored in the brain. And when we see a problem, we take that and then we retrieve the information based on the knowledge that we stored, and then we apply that, and then we solve the problem. That's why humans are very versatile. So what if we can store the information in computers similar to what brains are? There is no proof, there is enough proof that there are neurons and neurons are connected and wiring happens all the time as you are learning. So that much proof is there. But we don't know exactly how it retrieves and how it processes and all that. This is still scientific research. So from a modeling point of view, we can take advantage of that and then store it. So I'm going to now take the example of the keynote speaker, Eric Evans' speech today. So we have a banking system, so we can consider that as banking. And he said we have credit cards. And then he said cash accounts. So if I'm in the banking business, I'm doing this and I'm doing that. So that is, you look at that correlation. And then suppose because of some reorganization, we wanted to create business accounts and then personal accounts. Now suddenly this new requirement came, so we don't have to lose what we already have. That is the beauty of the brain. Brain always stores information, it never loses. Well, if you don't use it for a long time, you will forget it and then you will lose it. But otherwise it keeps everything. It keeps track of everything, what to do and also what not to do, both the ways. So if we are doing the reorg, all we have to do is to create these additional ones to preserve. So we can say, we can connect this and this, because that's how we want to run our business. We used to run our business cash accounts and credit cards. Because of a reorg, we wanted to run as business accounts and personal accounts. So we connect, and then we also connect this and this so that the business account now can be a cash account and a credit cards thing. It could be both, right? And similarly, personal and this. So now with these connections, you have preserved what you already have, and we reorged the organization to do business from now onwards. And then from now onwards, you are maintaining all these business accounts, but you can convert some of the existing accounts, whatever cash accounts and credit accounts, identify and then populate this, so that we can reclassify and then still take advantage of whatever data that is already there, still intact. At the end of the day, it's all connections. Those trillions of connections that is happening is similar to, by simply connecting, we can maintain the state. Now, if it is a stable state, it's not useful. So something has to change in order to something to be useful. If your bank transactions are not happening, there is nothing exciting happening. So you should be spending, you should be making money, and so that means because of a transaction, the data is coming and going. So there is a transaction. Okay. So this can be connected to this or to this, and because of these connections only, we will know whether it is a business transaction or a personal account transaction. Is it a credit card transaction or is it a cash account transaction? So you can deduct by traveling this hierarchy. So these layers and layers and layers of information connected, interconnected, like a big mess of pointers. And that's how the brain is storing layers and layers of information. And at the same time, at any given point of time, you need to know only two. This is the context. So if we want to use the DDD term, the bounded context, this is the bounded context. When I'm looking at this, these two neurons are activated in the brain. So when you are thinking about DDD Europe, there are few neurons that are lightning, and rest of all the neurons are silent, inactive, because you're not thinking about your office or anything. You're thinking about DDD, or you're not thinking about your old school friend. But the moment you think about your school friend, that neuron, and then related to that, those neurons are getting activated in the brain. So that's the thought process. It's basically a retrieval mechanism. If you consider that as a big database, and then you are retrieving efficiently. The thing is, it does this parallelly so fast that we don't even know what's happening. Am I in time? So by modeling in this fashion, so any complex system can be evolved very smoothly. So now you can pick up any problem, any business problem, you can organize, and then you keep on just making connections. Linking, delinking, linking, delinking. And that's what is happening in the brain, as far as we think. And because the brain doesn't forget things, so it is maintaining the old state and new state, both states. So you never delete anything. So it's a massive amount of information stored. The capacity is too high. So same thing, if we have a big capacity computer, then we don't have to delete anything. And that's my inspiration for the modeling and to make life easier. So we at Skillbank, I'm coming from Washington, D.C., and we have created a modeling platform to do on this, and we still are trying to enhance it to make it much more easier and easier. And I have worked with few clients in analyzing, doing event storming and extracting the requirements and prototyping in this fashion, because now I'm able to explain anything very easily simply by showing these connections.
How do you know if the transaction is a cash transaction or a credit card transaction? How is it linked?
Okay, so if you have a business account, so when you're doing a transaction, it has a parent, right? So if you put a transaction, either you have a parent this or this, not both. So once you have this, and then obviously when you do a transaction, you may do credit card or cash. So all you have to do is simply connect this.
Okay.
I didn't draw, but that's the basically the main point here is you should be able to connect anything to anything.
Okay.
That's the key. And that's how neurons are making trillions of connections. Thank you.
Thank you very much.